Excuse me, sir, I'm lost. I'm looking for a place where I can get lost. I'm looking for a home for my malfunction.
We can, just like any other toolkit function, we can transform them, right? So transforming exponential, I'll just abbreviate here, graphs. Okay, so it kind of works the same way as in any other graph. So for horizontal shifting, if you want to go left or right, you apply the shift directly to your x, okay? So we apply directly to the variable, I'll just say, to be general, to variable in the exponent, okay? In exponent. And again, this is, for horizontal shifting, it works a little bit backwards or opposite, because if we want to shift, let's say shift this graph 4 to the right, okay? And in order to do that, we're going to act directly on this x up here in the exponent. So what we really want is 2 to the exponent, which is given by x, and then minus however much we're shifting. So in this case, that would be a 4. So this would be the formula for a function which is 2 to the x shifted 4 to the right, okay? So it's something like that, and this is x minus 4, it becomes our new exponent, okay? And another thing to note is that whenever we shift, horizontally or vertically in this case, is that our vertical intercept changes as well. So let's say, for example, we're comparing 2 to the x versus 2 to the x minus 4, okay? So if we were to plug in a 0 for this one, we get 2 to the 0 is equal to 1. So our vertical intercept is 0, 1 for this one case here. And then if we plug in a 0 on the right-hand side, though, we get 2 to the 0 minus 4, which is equal to 2 to the negative 4, which is equal to 1 over 16. So here we have 0, 1 over 16. So these are definitely not equal, right? So we see that the shifting, even horizontal shifting, it affects our vertical intercept as well. All right, so now for the easier kind of shifting, we have the vertical shift. Okay, so to vertically shift something, you just take your original function and then you add c to it, and whatever that means. And it's a direct correlation here, meaning that if you want to shift up 2 units, you would just take, let's say our parent function was 2 to the x, and then just add a 2 onto the end. Or if you wanted to go down 2 units, it's really not that hard. You just tack on a minus 2 all the way at the end there, okay? Something else important to notice about vertical shifting is that, let's say we do have a function like this, okay, so 2 to the x minus 3. So before, when we had 2 to the x, our graph looks like this. Let me just draw a little quick sketch here. So we have, okay, so it looks like that, right? And then I'll just draw for you here, 2 to the x minus 3 looks like this. Then we'll have 1, 2, 3, 1, 2, 3. 1 and 1. So this is actually going to look like, let me see here, 1, 2, 3. And we're going to look something like this, okay, when we actually graph it. Because we see that all of our points are just shifted down by 3, right? So instead of 0, 1, now we're going to have 0, negative 2, which is the one down here, right? And then etc., etc., and we move all of the points, we shift them vertically down 3. And that also means that our horizontal asymptote, which started at, so over here on the left, our horizontal asymptote was at y equals 0, but now our horizontal asymptote is at y equals to negative 3. So like I said, our horizontal asymptote kind of moves accordingly to however we shift vertically. Okay, here's a final example to finish off this concepts video. We're going to sketch a graph of this formula here, which looks a little bit more difficult than the example we did before, but we can do it. We'll take this step by step. Okay, so let's break down what's going on here. So what I would like to do first of all, just because I have a disposition to not like fractions, is that I'm just going to change that 1/2 in here to a 2 to the negative 1 power. Okay, and then we'll deal with that accordingly. You could also deal with it as the 1/2 by itself, and you could take it as it is. But this is the way I'm going to do it for this example, okay? So this negative 1 and the x combine to make a negative x, and then we have plus 4. So now with this, we can identify what's really going on, okay? So this negative sign in front, that means that there's going to be vertical reflection, okay, which means you're going to be flipping across the x-axis. This 3 means we have a vertical stretch by factor of 3, by factor of 3. The 2, that just means our b is equal to 2, okay? This negative sign on the x up here means we have a horizontal reflection going on, and this will be across the y-axis. And finally, this plus 4 just means we're going to shift everything up 4, okay? So, a lot of stuff going on. We'll just break it down piece by piece, okay? So first of all, the whole parent or toolkit, I guess, function you could say, is behind everything is 2 to the x, okay? Let me just write our entire formula up here first of all. So we have negative 3 times 2 to the negative x, and then plus 4. And then we have a bunch of stuff happen to it, right? It's being transformed in multiple ways. So if we start with our 2 to the x graph, we're going to start with something like this. So we have x and y, 1, 2, 3, 4, and 1, 2, 1, 2. So we have something that looks like this. Let me just draw our sketch again. Okay, so this is 2 to the x. So let's say the first thing we want to do is get this negative sign on it. So that means that we have to horizontally reflect it. So we're going to move each of these points over. So instead of having 1, 2, we're going to have negative 1, 2. Okay, so the x value just changes signs. So we'll have something that looks like this instead. So it's an exponentially decaying graph. So let me write that on a separate one here. So we have x and y, 1, 2, 3, 1, 2. Okay, so we have something that looks like this. Alrighty, and this one here is our 2 to the negative x graph, okay? And you might also recognize this as 1/2 to the x. They're equivalent, okay? So now that we have that, now let's deal with the 3 part, the actual like vertical stretching, okay? So in order to stretch this, what we're going to have to do is the following. So we'll have 1, 2, 3, 4, 5, 6, 1, 2, 3, 1, 2, 3. So instead of having just, so now what we want to do is construct this 3 times 2 to the negative x. Okay, so we're just adding on to it. We're going to do one transformation at a time, right? So instead of having this here, this 0, 1, instead when we plug in a 0, let's see what we get. So we have 2 to the 0 times 3, so that's 3 times 1. So now we're going to have our vertical intercept is going to be 0, 3, okay? And then let's say we have a negative 1. If we plug in a negative 1, we would get 3 times 2 to the 1 power. So we just get a 6. So that would be the point negative 1, 6. And now, lastly, let's just plug in a positive 1. So if we do a positive 1, we get 3 times 2 to the negative 1, which is the same as saying 3 times 1/2, which is 3 over 2. Okay, so 1 gives us about 1.5 here. Okay, so now we're at a graph that looks like this. Okay, so we just had a vertical stretching or scaling by a factor of 3. Okay, now the next thing is to add on a negative sign in front. So if I just do this on this slide right here, or on this graph, what that means is we're just going to add in a vertical reflection across the x-axis. So we're just going to drop everything below to its corresponding point below the x-axis, okay? So in order to do that, instead of having negative 1, positive 6, we're going to have negative 1, negative 6, so somewhere down here. And then our next point is going to be 0, negative 3 instead of 0, positive 3. And 1/3, 1/2. The point 1, 3 over 2 is going to become 1, negative 3 over 2. So something like this. So it'll just reflect across the x-axis there. Okay? So now, this last thing, so now we're here at this point. Okay, we're down there, and this is what we're at as far as our formula. And the very last thing that we need to do is to add 4 to it. So just shift everything up by 4 units. Okay? So let's just draw this. We're just going to sketch out this last graph here. Okay, so now 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, and 1, 2. Okay, so we were at the point negative 1, negative 6. Okay, but if we add 4 to that, we get negative 1, negative 2. How about if we add 4 to 0, negative 3? So now we'll go up 4 units, so 1, 2, 3, 4. So up here, okay, if we add 4 to 1 comma negative 3 over 2, so we were at 1 comma negative 3 over 2, 1, 2, 3, and 4. So now we're up here at this point, okay? And then if we were to draw our graph, we'd get something like this, okay? And we see that we actually have our horizontal asymptote moved up by 4 units. So instead of being here at y equals 0, now it's going to be up here at y is equal to positive 4. Okay, and this is it. This final thing on the bottom right corner, this is the sketch of our graph. Okay, so that concludes our concepts video on graphs of exponential functions. I hope that helps, and I'll talk to you in the practice problems video if you watch.